In this video, let's connect our Spring Boot application to a MySQL database hosted on Microsoft Azure. I will also demonstrate how to use Azure Key Vault to securely store application secrets, such as the database login credentials. But first, let's briefly review what we have done so far in terms of deployment. In the previous videos, we built and packaged our Spring Boot application into an executable jar file, containerized the application into a Docker container, and then deployed this container to Azure Web App Service. By the way, you can find those videos in the description of this video. As you can see, the deployed Spring Boot application returns this JSON message as a response to this API call. Everything looks okay. However, the data is currently stored in an in-memory database called H2. Although it is very convenient to use an in-memory database during development, just adding a dependency in the pom.xml file and you have the database ready. It is not a good idea to use it in production. In-memory databases do not provide persistent storage. Recall that we need to populate the H2 database when the application starts, and be prepared to throw away the data when the application shuts down. In production, we need to use a beefy production-grade database that can handle mission-critical workloads with predictable performance and dynamic scalability. So first, we will provision a MySQL database in Azure. Does that mean we will throw away H2 database completely? No. As I said before, during development, it is convenient to use H2. And you don't want to connect to a production database during development, right? That means we need to find a way to tell Spring Boot when to use which database. For example, in the development environment, it will use H2. But once the code is running in a production environment on Azure, Spring Boot needs to switch to MySQL. How can we achieve this? That's our second task in this video. Finally, our Spring Boot application needs login credentials to access the MySQL database in Azure. So where do we store the login credentials? Do we hard code them directly inside the application code or store them somewhere else? What is the best practice? It turns out that we need to store those credentials in something called Key Vault. That's our last task in this video. Let's get the three things down one by one. First, let's provision a MySQL database in Azure. Let's go to the Azure portal. MySQL is a popular open source relational database. It is supported by all major programming languages and cloud platforms. It has strong community support and a rich ecosystem of tools. So let's create one in Azure. So let's click Create a Resource. And here we're going to pick Databases. Microsoft Azure offers Azure Database for MySQL, which is a fully managed platform as a service running the MySQL Community Edition database engine. So we can quickly provision and scale a MySQL database server in Azure. So let's create one. As you can see, there are also other choices of databases here. So let's create Azure database for MySQL. And let's create a flexible server. Okay, first, make sure you pick a subscription. So this one is good. And then pick a resource group And remember, a database server is also a resource. So let's put it inside. Now in this case, I only have one resource group. It's called Hogwarts Resource Group. Recall that a resource group is like a folder that groups together all the resources needed by one project. Here, let's give a name to our server. Let's call it Hogwarts-database. The server name is a unique name that identifies our flexible server. The final domain name of our database server will be hogwarts-database.mysql.database.azure.com. This is called a fully qualified domain name, or FQDN. For region, just choose the location that's closest to our users. We're using MySQL 8.0, that's good. Workload type is for development or hobby projects. Feel free to change this as you see fit. For compute and storage, let's click Configure Server. Here is where we can configure the compute, storage, IOPS or IOPS, and backup configurations for our database server. The storage we provision is the amount of storage capacity available to the database server and is billed gigabyte per month. For backups, we can configure automatic server backups that can be used to restore our server to a point in time. In this video, I'm going to keep everything to default. Change them as you see fit. So save. Next, we need to select the authentication method. In this demo, I will only use MySQL authentication. Let's enter an admin username. I'll call it headmaster. And maybe this is the headmaster of the Hogwarts Magic School. Let me remind you that the admin login name cannot be Azure superuser or simply admin, administrator, root, guest, or public. Okay, next, let's set a password for this admin. Confirm the password. So they match. Here, I want to make a comment. Since this is a one-man project, just me, I am playing two different roles or wearing two different hats here, developer and database admin or DBA. In a real-world scenario, different people will wear those hats. So now, I am wearing the hat of a DBA. As a DBA, I will never reveal those login credentials to my colleagues in the dev team. The dev team has no access to the production database. So during this video, you will see a picture of me wearing different hats in the upper right corner of the video, reminding you my current role. So pay attention to that. Next, let's configure networking options. On the networking tab, we can choose how our database is reachable. In other words, control connectivity to our Azure MySQL server. Azure supports two types of network connectivity methods: public access with allowed IP addresses, private access with VNet or VirtualNet integration. When we use public access, our database server is accessed through a public endpoint. The public endpoint is a publicly resolvable DNS address like this. Access to the database server is limited to the allowed IP addresses that we add to the firewall rules. This method prevents external applications and tools from connecting to our database, unless we create a rule to open the firewall for a specific IP address or range. When we use private access VNet integration, access to the database server is limited to our virtual network. This is considered the most secure connectivity method. In this video, let's focus on the creation of a MySQL server with public access. For configuring firewall rules, check this Allow public access from any Azure service within Azure to this server. And also click Add Current Client IP Address. Because later on, I will use a tool called MySQL Workbench on my machine to connect to this database. So I need to add my IP address into the allowed IP addresses. Remember, you cannot change the connectivity method after you create the database server. For example, if you select public access with allowed IP addresses, when you create the server, you cannot change it to private access with VNet integration after the server is created. I would like to make a comment here. In a real-world production scenario, Azure highly recommends that you create a database server with private access to help secure access to the server via VNet integration. The DBA will then need to use either VPN or Azure Express Route to access the production database. I think that's too much for one video, and I may discuss that in a future video. But for now, let's demo the public access. Let's click Next to Security Options. I'll keep this to the default. Then Review and Create. Provisioning a database server can take a few minutes.
2,000 years later.
Almost there. Okay, finally, our database is deployed. So let's go to this resource. Here is the server name and server admin login name. For MySQL servers created with public access connectivity method, you can get started quickly with a built-in MySQL command line client tool by clicking this Connect button in the overview page right here. So click here. As you can see, this brings up something called Azure Cloud Shell, and it says you have no storage mounted. It's asking to create a new storage account. That's fine. So let's go ahead and click Create Storage. Okay, very good. Let's log into our MySQL server using headmaster as the login name. Now I need to enter the password. And let's try this command, show databases, semicolon, and return. Now, as you can see, MySQL server comes with 4 databases. If you like, you can use this to interact with the MySQL server, but I'm not going to use this terminal for database administration. Instead, I will use MySQL Workbench to design and manage databases. So let's first go to the Connect page and view more details on how to connect the database with MySQL Workbench. So let me close this and click Connect right here. And let's click here. Here are the instructions for connecting to MySQL Workbench. And let's click here. Here are the connection strings for different programming languages and frameworks. Pay attention to the JDBC. That's the one that will be used in the Spring Boot application. I have already installed MySQL Workbench on my computer. Let's go there. MySQL Workbench is the official graphical user interface tool for MySQL. It allows you to design, create, and browse your database schemas, work with database objects, and insert data, as well as design and run SQL queries to work with stored data. But first, let's make a connection between MySQL Workbench and our MySQL database in Azure. So let's click here. And let's give this connection a name. So let's call it Hogwarts Artifacts Online. Then what is the host name? Let's go back to Azure. And scroll up. It is right here. Copy this. And paste it here. And the port is okay. Now the username should be headmaster. And for password, so let's click here and input the password. Click OK. All right, everything looks good. So let's click Test Connection. Good. Successfully made the MySQL connection. So click OK and click OK. Then let's double click this tile. Now we're opening SQL Editor. Let me click Schemas. In MySQL Workbench, let's create the Hogwarts database, tables, and populate the database with some initial data. I have prepared the statements, and you can find those statements in the description below this video. Let me copy and paste them here. So it's pretty long. Let's briefly go over those SQL statements. First, we create a database called Hogwarts. Then we use this database. Line 22 to line 32 create the artifact table using createTable DDL statement. Line 40 inserts some artifacts into the created table. So let's look at the first one. Deluminator. So this is the ID, and this is the description. This is the name of the artifact, and this is the ID of the wizard that this artifact belongs to. So here I put production DB in the name of the first artifact to indicate that this data is from the production database, not from the H2 development database. You'll see this later on. Okay. Then if you scroll down, we'll create other tables. So this is a table for Hogwarts user. And line 67, we insert 3 users into this table. And so on. Okay, next, let me select all the SQL statements and execute them all. They're all good. And let's verify that. Let me refresh. And as you can see, we have a new database called Hogwarts. And if you expand the tables, we have artifact, user, wizard. Okay, now let's look at what is in table artifact. Select from artifact. And let's execute this line. As you can see, this table has 6 artifacts. Let me remind you that I am now the DBA. It is the DBA's responsibility to create the table or schema and initialize the entire database. Great! We successfully provisioned a MySQL database in Azure. Next, let's configure our Spring Boot application so that it can connect to the production database. Let's go to IntelliJ. Now I am wearing the hat of a developer. I'm no longer DBA. Look at the image in the upper right corner. Since we will modify our Spring Boot application, we'd better start with a new branch. So git branch. Let's call it MySQL database connection. Git switch to MySQL database connection. In Spring Boot, we need to first install the official JDBC driver for MySQL. And we can do that by simply adding a new dependency inside the pom.xml. And let's do that. First, let me close this and open pom.xml. And let's scroll down. We don't need this empty line. And let's put it after the H2 database. Well, the order of the dependencies doesn't really matter. So here we have a dependency. And the group ID is com.mysql. Okay, great. And the artifact ID is mysql-connector-j. And also, let's add a scope and make it runtime. And then we're going to click this refresh button, resolving the dependency. Good. All right, next, let me close this. Let's go to the application.yaml file to do some database configuration. src main java resources, and right here. Recall that during development, we used the H2 in-memory database because it is so convenient. So in this application.yaml file, we defined some configurations for this H2 database. As you can see, we have data source URL, username, password, and driver class name. Here, we also indicated that we want Spring Data GPA to log the auto-generated SQL statements into the console, so it's easier for us to debug. Also, if you still remember, when the application starts, this DB data initializer Spring Bean will be loaded and populate the H2 database by inserting some testing data like this. Okay. However, as I said before, during production, we would like to switch to a real database like MySQL. So we also need to define similar configurations for our MySQL database, right? What should we do here? Well, maybe we should define those configurations in a separate application YAML file like this. So I will copy this application.yaml, copy, and paste. But give it a different name, application-prod. Prod stands for production. Enter. So now we have 2 copies. And here, maybe we'll give it a better name. Right-click and rename. Follow the same naming convention, -dev or dev. Dev for development. Okay, do refactor. All right. So in application-dev.yaml file, we configure H2 database. While in application-prod.yaml file, we're going to configure our MySQL database. So here, we're going to change this to the URL of our MySQL database in Azure. So here, let me put a comment. URL of MySQL in Azure. And this is the admin username of MySQL. And here is the password of admin of MySQL. And we do not need the driver class name. Spring Data GPA is smart enough to figure out what is the correct driver class name. That means here we can also safely get rid of line number 6. So line number 6 is optional. It's okay to put it there, but you don't have to. All right. Now, in a production environment, we do not want to show SQL statement. So you can either change this to false or simply just get rid of this, because by default, this is false. But we're going to add an additional property. It is hibernate DDL-auto, and we're going to set it to none. So here is a comment. We explicitly turn off the DDL or data definition language auto generation. Here we did two things. First, we turned off the show-SQL option in the production environment. Second, we turned off the DDL auto generation. That is, we do not let Spring Data GPA manipulate the production database schema or table at startup. Because remember, it is the DBA's responsibility to do that, not Spring Boot. This is very different from development environment. Also, we want to deactivate this class, DB Data Initializer, when Spring Boot is running in production environment, because you don't want our application to insert testing data into a production database every time it starts, right? Okay, but wait a sec. Now there are two application YAML files under resources. How does Spring Boot know which one to use when our application is started? Will Spring Boot get confused? Well, the solution is Spring Profiles. Spring Profiles can control which configuration is loaded in a certain environment. For example, development and production. To be more specific, a Spring Profile decides which application properties are active. So are the properties here active or the properties here active? That can be determined by Spring Profiles. A Spring Profile can also decide which Spring Beans are active. In other words, which Spring Beans are loaded into the application context. So it can decide whether this DB Data Initializer is active or inactive. Okay, so now let's define two profiles, dev and prod, to represent the two environments, development and production. So how do we define a Spring Profile? It is simple. Let's go to the application.yaml. And right now, it does not exist. So let's create one. And tell Spring Boot that at this moment, we want this application to run in the dev profile. Here is the syntax. Spring Profiles active. That's it. Make sure you define the 3 lines under application.yaml. Please note, there are 3 application YAML files under resources. When Spring Boot is started, it will first read this application.yaml to decide what is the active profile, in this case dev. Then, Spring Boot will try to load profile-specific files using the naming convention application-profile name. In this case, both application.yaml and application-dev.yaml will be considered, while application-prod.yaml will be ignored. because prod is not active, right? Remember the order. Application is loaded first, followed by application-dev. So the properties in application-dev may override some properties you define in application. Just pay attention to that. Since application.yaml will always be loaded first, let's migrate the common settings of the two profile-specific YAML files into this application.yaml file. So click here, and we compare with application-prod, and we find that everything here is duplicated, right? So let's do a cut and go to application.yaml and paste. Okay. Now make sure you don't mess up the indentation. Profiles, MVC, web, so they're on one level under Spring. Now API here, there's no space. And then we have endpoint, base URL, server, there's no space here, and the port belongs to server. Okay. And then let's go to application-dev.yaml, and we can safely delete this part. All right. Now we have simplified application-dev and application-prod. The common settings are moved to application.yaml file, and they can be shared by the two profile-specific files, of course. Configurations specific to dev profile are placed in application-dev.yaml file, and configurations specific to prod profile are placed in application-prod.yaml. Everything is nice and clean. Okay, so that's for configurations of H2 and MySQL databases. So they're in two different YAML files. Now, what about this guy here? Now remember, we only want this DB data initializer to be active when the current profile is dev. And how to do that? Spring profiles make it easy to activate and deactivate specific application components depending on environment in which it is running. So here's how we do that. It's very simple. We're going to introduce a new annotation. Add profile. And then pass the profile name, dev. This annotated class, DB data initializer, will be loaded only when the application is running under the dev profile. It won't run under the prod profile. So this is a pretty useful annotation. It can control which Spring Bean or component is active or inactive. What about test cases? Remember, we created many test cases. And test cases are only supposed to run under profile dev. So let's configure our test cases to make them work well with the dev and prod profiles. Now here, let me introduce a second very useful annotation about profile. Now this time we're going to use @active profiles. And here, okay, see, value is equal to dev. So here, value equals is optional, okay? Then what is this active profiles? And is it different from @profile that we used for DB data initializer? They are different. So this is a powerful annotation that declares the active profile or profiles to use when executing this test class, regardless of the current active profile. In other words, line 32 will override the active profile we defined in application.yaml. We're saying here that we want to execute this test class with this specific profile dev, even though this profile is different from the current active one defined in application.yaml file. So it's pretty powerful. Please note, this annotation is only used for test case classes, like here. So next, let me put this annotation to the 10 test case classes. And don't forget this one. Okay, let me close all of them. Let's do a simple test. Okay, now remember, right now the active profile is dev. So if I launch the program, okay, so if I scroll all the way up, all right, so look at this line here. The following one profile is active, dev, right? So this one corresponds to right here in application.yaml. And if you scroll down, as you can see, Spring Data GPA automatically generated those DDL statements. Okay, and here, look at those insert statements. That means that DB data initializer here is active. Okay. Now let me turn it off. And now let's switch to prod. So now we're indicating that Spring Boot should run in prod profile. So let's run this program again. Now this time, as you can see, this log is shorter. So let's scroll up. So first of all, it says the following one profile is active, is prod. Okay. As you can see here, that DDL auto is turned off, so you cannot see any DDL statements. But you probably wonder why H2 database is enabled in prod profile, right? It is because in the application-prod, we didn't specify any data source. As you can see here, those are comments. Those are not real URL, username, and password. So in this case, Spring Boot is smart. Spring Boot will use H2 as default. Now later on, when I fill those out, we're going to connect to MySQL instead of H2. Okay? But I also want to let you know that this is a feature of Spring Boot, that if no data source is provided, it will default to H2. All right, now let me turn it off. Remember, now the active profile is prod. Let's try to execute all those test cases. So right-click and run tests in Java. So before I click this, think about this. Will all the test cases run? Let's see. Okay, even though the current active profile is prod, all the 89 tests are still running, right? Why? Thanks to @active profiles, it overrides the active profile we defined in application.yaml. Okay, so hopefully you have a good understanding of Spring profiles. Let me change it back to dev and close this. All right. Recall that I am wearing the hat of a developer. I'm no longer a DBA. Then what about the three values here? The URL, username, and password of the data source. They cannot be empty, right? And you saw that if they were empty, Spring Boot would default to H2 database. That's not what we want. Let's take advantage of something called Spring Property Placeholder. Okay. So here is the syntax. $, and a pair of curly braces. And for this, I'm going to write a placeholder, data source dash URL. And the same thing here, data source username. Data source password. Those placeholders will be resolved by Spring Boot once our application is deployed to Azure Web App Service. In other words, those placeholders will be replaced by the real URL, username, and password after our application is deployed. Very good. Now let me switch my hat back to the DBA. Now I am wearing the DBA's hat. As a DBA, it is my responsibility to securely store the database login credentials. You should never hard-code database credentials in the application's code. You don't want your dev team to know the database password, right? Then where do I store those credentials? If you search the internet for a solution, you will see many people storing the database login credentials in environment variables on the production server. That works, but I think we should use a dedicated credential management solution, like a Key Vault. This is considered the best practice for DBA. So next, let's go ahead and create a Key Vault in Azure to securely store database login credentials. Okay, so let's click Create a Resource and search Key Vault. Okay, it's right here. So let's create Key Vault. All right, so pick a subscription as usual, and then assign this Key Vault to a resource group. Now in our case, it's Hogwarts resource group. And let's give this Key Vault a name. Hogwarts Key Vault. Region is good, pricing tier is good, and the default recovery options are good. Okay, next. For permission model, let's use the recommended Azure Role-Based Access Control, or RBAC. Okay, everything's okay. Okay, so let's go ahead and create. Okay, so the Key Vault is deployed. Let's go to the resource. As you can see, in a Key Vault, we can store keys, secrets, and certificates. Basically, you can store anything that is confidential. In this case, let's create 3 secrets to hold the database login credentials. All right. If you are creating the Key Vault with RBAC role from scratch, like what we did, then you need to first assign the role of Key Vault administrator to yourself for managing the secrets. Otherwise, as you can see, you cannot create anything in this Key Vault. So let's go to Access Control and click Add Role Assignment. All right. As you can see, in RBAC, there are different kinds of roles. And here are the descriptions of those roles. Now remember, we're looking for Key Vault Administrator. So it's right here. So select and click Next. And it's a user. Select Members. And here is my name. So click here and click Select. So we're assigning the role of Key Vault Administrator to myself. Review and assign. Okay. All right, good. Now it's time to set some secrets. So let's go to secrets. Now recall that in application-prod.yaml, we defined 3 placeholders. And those 3 placeholders will be replaced by 3 values that are stored in this Key Vault. So let's define 3 key value pairs. So the first one is data source URL. And here is where you can find the URL of our MySQL database. So come here, scroll down, it's this one. Copy. And first, let's go to a text editor and replace this one with the name of our database, which is Hogwarts. So this is the URL of our data source. So let's copy this and paste here. That's the secret value. Paste here. And here, of course, you can set activation date and also set expiration date. But in this case, we don't set them. That means the secret is permanent, never expire. And create. Now, next, let's create the second one. Data source dash username, and it is head master. Create. Then let's create the third one. Now, this time is data source password. And you should input your password. Create. Okay, very good. Recall that we deployed our Spring Boot application to an Azure Web App Service. Next, we need to configure the Web App Service to connect to the Key Vault so that our Spring Boot application can retrieve those 3 secrets. So let's go to the Web App. Recall that we first deployed to this staging website, hogwarts-artifacts-online/staging. So once our Spring Boot application is deployed here and it works fine, we're going to swap it with hogwarts-artifacts-online. So actually we have 2 web app services. So let's click into this one first. In Azure, access to a key vault requires proper authentication and authorization. If you still remember the difference between authentication and authorization. Key vault authentication is done via managed identity and Microsoft Entra ID. Authorization is done via Azure role-based access control, or RBAC. So let's first enable the managed identity for our web application. So let's click here, identity. By default, it is not enabled. So just turn it on and save. Enable system assigned managed identity. Okay. So as you can see here, the managed identity is authenticated with Microsoft Entra ID. So you don't have to store any credentials in application code. This is for Key Vault authentication. As far as authorization, let's go back to Key Vault and go to access control, and we need to assign a role to our web app. So click add role assignment. Now this time, we're going to assign Key Vault secret user. So as you can see here, a Key Vault secret user can read secret contents. We're going to assign this role to our web app. So go to next. And this time, let's select managed identity and select members. App service. This is the managed identity. Click here and select. Review and assign. Now, the DBA's job is done. Let's switch hats again and go back to IntelliJ. I know I wear too many hats. Sorry about that. To support Azure Key Vault in Spring Boot, we need to install the Spring Cloud Azure Key Vault starter. Let's add a new dependency in the pom.xml. So let's scroll down and find the last dependency. All right, so let's add a new dependency. com.azure.spring. And this one is Spring Cloud Azure Starter dash Key Vault. Okay. And let's get rid of the version. But remember that 5.6.0. Okay. That's not enough. We need one more thing. Paste. Okay. Okay, so this is the Spring Cloud Azure Bill of Materials, or BOM. Again, make sure you don't mess up the tags. Now here it is referring to a version, Spring Cloud Azure.version. So we have to define it in the properties tag. So let's scroll up. Okay, right now there is one java.version in properties. So here, let's do this one. And 5.6.0. So our Spring Boot application will use the methods provided by Spring Cloud Azure to read secrets from the Azure Key Vault. And make sure you load Maven changes. All right. Spring Cloud Azure has several methods for reading secrets from Azure Key Vault. In this video, we will use something called Spring Key Vault property source to read secrets from the Key Vault. Let me show you how to do that. So let me close this and go to application-prod.yaml. Recall that the three secrets are stored in Azure Key Vault. So Spring Boot needs to know where the Key Vault is. So in this YAML file, let's tell Spring Boot the Key Vault endpoint. And here is the syntax. Cloud, Azure, Key Vault, secret, property-sources 0, which means the first property source in this array, endpoint. Then what is the endpoint of the Key Vault? And you can find it here. Go to overview of the Key Vault. It's right here. However, I do not want to hard code the endpoint URL here. What if in the future the DBA or a cloud engineer changes the endpoint? And also, I don't think it's a very good idea to expose the endpoint URL of our Key Vault in the application code, right? Remember, we're going to push this to GitHub, and everyone may see this. And this time, we're going to reference an environment variable. And here is the syntax. Azure _ Key Vault endpoint. So here is the environment variable. And those three are secrets from Azure Key Vault. Please note, I chose the format of those names very, very carefully. For environment variables, they are all caps separated with underscores. For secrets in Azure Key Vault, they are all lower cases separated with dashes. So you won't get confused. One environment variable, three secrets from Azure Key Vault. All right, then let's go to Azure portal and set this environment variable. Then where do I set environment variables for a web app service? So it's right here. Click Configuration, and we can use Application Settings. So let's create a new application setting. Remember the name? It is Azure Key Vault Endpoint. And the value is, let's go to the Key Vault, copy this, paste here. Let's click OK. Let's create a second one and call this Spring underscore profiles active. And the value here is prod. Here, I want to make a comment. There are many ways you can configure the active profile for Spring Boot application. I showed you one, is that you can configure that in application.yaml. The second way to do that is through environment variables. If both exist, environment variables have higher precedence and will override the values you set in the application.yaml file. So after deployment, the active profile becomes prod. But in the IDE, it is still dev. Click OK. Now remember, don't forget to click Save. Next, let's go back to IntelliJ. Now we're ready to commit and push. But before that, since we changed our application code, let's test locally. Okay. And here, let me make a comment. By default, the active profile is dev. During production, it will be replaced to prod due to Azure's environment variables. Okay. All right. Close this. So let's go ahead and commit and push the code to GitHub. Git add, git commit, connect to Azure database for MySQL with Azure Key Vault. Git push. Okay, then let's toggle over to GitHub. Okay, as you can see here, MySQL database connection had recent pushes less than a minute ago. So let's compare and create a pull request. So if you scroll down, you can see the changes we made. So here is in the POM. We add MySQL connector J. We add Spring Cloud Azure Starter Key Vault. And then we add this add profile annotation to DB data initializer. And we changed the 3 YAML files. And then we add this add active profiles annotation to 10 test case classes. Okay. So let's create a pull request. Now recall that creating a pull request will trigger the Java CI with Maven. So we can go to Actions and click here. It will take a while.
2,000 years later.
All right, so the build is successful. Let's go to pull requests. And let's merge the pull request. And this will trigger the build and deploy workflow. Confirm merge. Great, the deploy is successful. So let's go to the staging site and look at the result. And let's click Browse. And let's go to API v1 artifacts. So as you can see, this one still shows the old version, Deluminator, okay? Because you know deployment takes time. So let's wait a sec. So let's go to the staging site and look at the deployment center and look at logs. Okay, so let's go here and refresh. Okay, now finally, as you can see here, the name changes to Deluminator Production DB. So that indicates that our Spring Boot application is pulling data from the MySQL database in Azure, not the in-memory database H2. We can also verify that by going to the current production site. So let's go back here, staging, go to home, and let's go to the Hogwarts artifacts online. Remember, this one is the production slot. So let's go here and browse. Now this one will show us the old one, API v1 artifacts. Now, so this one is populated from H2 database. So this is name is Deluminator, but the staging site says Deluminator Production DB. All right. Next, recall that we can do a swap between the staging site and the production site. However, there is a catch. I will show you later. Okay, so let's go to here. Let's go to deployment slots. And let's do a swap. So here, the source is the staging site. The target is the production site. Now, in this case, during a swap, the application settings or the environmental variables that we set in the staging site also get swapped to the target. So as you can see here, in the target, the old values for the three settings are not set. But after swap, they will have the same values as the values in the staging site. Okay? However, there is a problem here. Do you remember something called managed identity? We enabled managed identity for Hogwarts Artifacts Online staging site, but not for this production site. When swapping slots, the managed identities remain tied to the slot. They don't swap. Since right now the production site has no access to the key vault, and this will cause a swapping problem. So before I click the swap here, let's also enable the managed identity for this production site, Hogwarts Artifacts Online. Now remember, managed identity is for authentication. Now we also need authorization. So let's go back to Key Vault. Let's go to Access Control, Add Role Assignment. Similarly, let's select Key Vault Secrets User. Go to Next. Managed Identity. Select Members. And this time, let's add Hogwarts Artifacts Online. Select, Review, and Assign. Okay, so now, if I go back to Hogwarts Artifacts Online, Deployment Slots, so both the production site and the staging site have access to the Key Vault. Now it's okay to swap. So let's click Swap. Swap.
2,000 years later.
Okay, great. It says successfully completed swap between slot staging and slot production. And let's test. Now recall that this is the JSON response from the staging site before the swap. So here the data is from the MySQL database in Azure. And now let me reload the page. Okay, the name is just Deluminator, because now you know that this one is from H2 database. Now let's go to the production one. Now as you can see, this is the JSON message before the swapping. It was retrieving everything from the in-memory H2 database. After swapping, Spring Boot will retrieve the data from our MySQL provisioned in Azure. And let's test. So refresh. Okay, great. Everything is perfect. Next, let's go back to IntelliJ and synchronize the local main branch. All right, now let's update our local main branch. Git switch to main. Git pull. All right, then our local main branch is synchronized with the remote main branch. We're good. In summary, in this video, we provisioned a MySQL database in Azure, switched between dev and prod environment using Spring profiles, and securely stored database login credentials using Azure Key Vault. In the next video, we will learn Spring Boot Actuator. It will help monitor our application, gather various metrics, and understand traffic or the state of our database. See you there.